Hello everyone, my name is Timothy Lee Grant, and today I am going to be doing a Leetcode question, but today it's going to be a little bit more chill, a little bit more relaxed. If I solve it, that's great. If I don't, then that's fine, okay. I will just, I'm not even going to try to dig into it if I can't solve it. That'll be for tomorrow. I got off work today. I'm feeling, I have a little bit more energy. Just want to do a problem, see if I can get it. So we're in the trees section right now, and let's go look at a good one for a tree. So how about this one? Unique binary search trees. Sure. Let's look at it. See what this is doing. Okay. So, given an integer n, return the number of structurally unique binary search trees. Binary search trees which has exactly n nodes of unique values 1 through n. Okay, so first off, I read that sentence. I don't even know what it means. I'm going to have to read it again. All right, so we're given an integer. Okay, so let's just say 5. Okay. Wait, hold on a second. I've tried this problem. I've looked at this problem before. This is like combinatoric. This is not a binary. This isn't a tree problem. We're not doing this problem. I'm trying to stick to, the tree problems, learning tree problems right now, and then later on we'll learn other topics. But right now we're just focused on trees. That's not a tree problem. That's combinatorics. That's dynamic programming. We're not doing that. We're doing trees right now. So, construct binary tree from preorder. That sounds like a real problem. All right, here we go. Construct binary tree from preorder and inorder traversals. Okay, so we have these preorder and inorder traversals. We'll have to remember preorder means you process first. Inorder means you process in the middle, and then post order is you process that node at the back. Okay. So like, for example, I come here, I start at the root, and do I process it now? Well, in a pre-order, yes, I would first process it. Once I get to the node, I immediately, bam, process it, okay? So let's go through like what a pre-order traversal would be. Come here, process. Now, something kind of interesting, you normally just like by convention go left, right? But what I'm trying to do is think about different ways that I can change things or flip things around or modify things, right? And what the effect would be. There's no rule that says I have to go left. I could go right. Now, there is, as I just said that, something came into my head and I said, wait, hold on a second. But these trees are constructed in such a way that these nodes, the information within these nodes kind of means something, right? Like the value in which these nodes are placed means something, right? So yeah, I guess that's the difference. But then what is that? How are they placed? I know that what was it? I forget which type of tree, but I think it's binary search tree. You have all of the smaller nodes in the left and all of the bigger nodes in the right, something like that. And then you have to do balancing and all of it. I haven't gotten there yet, but I'm just thinking through this. Okay. Anyways, so given two integers, preorder and inorder, where preorder is preorder traversal of a binary tree. Okay, inorder is an inorder traversal. Wow, novel stuff there. Okay, traversal of the same tree. Construct and return the binary tree. Construct and return the binary tree. What? What is that supposed to mean? What am I supposed to return? Let's see. Definition for a binary tree. So here's the class, right? Okay. Now we have return type is a tree node. Okay. But if I'm given a tree, oh no, I'm not given a tree. I'm given two integer arrays. Oh, I see how this is a problem. Okay. Because I was thinking that they give me an in order like a tree, and I need to return an in order tree or something like this. And I was, what's going on here? Okay, so they gave me an array, two arrays. One array is preorder, and the other is in order. And now from that, I need to construct a binary tree. Oh, I see. I mean, I understand the problem now. I don't see how to do it. Big difference. Okay. Three, 9, 20, 15, 7. So yeah, this is preorder, right? Process, go left, process, go left, but nothing. Go right, nothing. Process, process, nothing, nothing. Process, nothing, nothing. So that's this right here, okay? And then in order is here, then here, then here, process, 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 like that, okay? But how do I construct? And let's see, I'm given it's a list of integers. These are not nodes. I have to create the nodes myself. Okay. And I guess one of the questions that I would have is, well, if I'm how do I know which one is a child and which one is... It must have something to do with, that's why they gave me two, an in order and a a preorder and an in order, because the discrepancy between them gives some information about the which one is a child and which one is not. Because, like, for example, what I'm thinking is this preorder, I could technically have one long string. Imagine 3 here, then 9, then 20, then 15, then 7, right? It's all left children. And that would be the preorder traversal of that tree. But it would not be the in order traversal of the tree. Okay. So what does it mean to be like, what does it mean if a node is a preorder but is not an in order? So Preorder is always going to tell me so the left, okay, in order tells me the leftmost node, right? I'm just looking at these arrays and trying to look at this picture and see if I can find any patterns. So in order, 9 is the leftmost, then 3 is the second leftmost, then 15, then 20, then 7. Okay. Preorder kind of shows top to bottom. So we have 3 here, 9, 20, 15, 7. So I know I have to start at the top up here at 3. So I start at 3, but then how do I map, like, what is the connection there? Hmm. All right, well, this is a very interesting problem, and the reason I say it's interesting is because I feel that this is extremely like fundamental to the idea of trees, and it's good that I'm having such difficulties right now because I'm going to be able to catch my major misunderstanding. There's some major like some conceptual thing that I'm missing. So I'm gonna come here to the solutions. Again, if I look at the solutions, I can't quite figure it out. That this is gonna be fine. I'll watch videos of it as well tomorrow. I'll try to refresh myself. I'll try to understand it. But this is a very good candidate problem for a problem that I really want to drill into to understand it. Okay. So I'll show you 2 ways to solve it here. There's a hint in preorder array because the first number is 3 is definitely the root. Yeah, I kind of got that, right? Where 3 is in order. We can find 3 at index. That means the left side of 3 in order. Okay. Array is all the left nodes in the tree because in order traversal is like left, root, right. We usually find left nodes before we find root nodes. Okay, I believe you can now guess all right numbers of 3 in order array should be all the right nodes. Hmm. Okay, well, there's a lot of information going on in that problem. It's almost midnight right now, so I'm not gonna even try to understand all that. I'll probably, after I finish this video here, probably go and watch maybe even this person's YouTube video themselves. Obviously, I can't play that video on my video because that's like copyright stuff. Can't do that, but I'll watch the video offline, try to understand this, and then come back either tomorrow or the next day. I'm in Portland right now, but I need to drive up to Seattle after I finish work tomorrow, so I might make a video. But, anyways, I will be focusing on this problem because I think it's a pretty good one, and this is my next. I'm kind of like focusing in on one problem at a time, and then like bam, got that problem. Okay, go to the next one. No longer am I just doing a whole bunch of problems. I'm trying to do it very targeted. So I think this is a good one for me to focus on and really understand what's going on, why I'm having difficulty with it. So yeah, I will follow up with another video in the near future. If that's interesting, subscribe. And I hope everyone has a wonderful rest of the day. My name is Timothy Lee Grant, and have a good night.